Okay, it's time to start. Good morning and welcome to the 10th lecture. Today we will be updating the class diagram and sort out the different kinds of relations we have in UML in class diagrams once and for all, I hope. So we will be doing some updating of this class diagram. Then we will talk about the rest of the gang of 4 patterns, namely composite and visitor, and we will do some more coding examples of those. First of all, a gentle reminder, don't forget to submit your workshop results today at 12 so that I can distribute the peer review form as soon as possible, because there is quite a short amount of time to do the peer reviews. So please abide by that deadline so we can get started as quickly as possible. And after this you will have until September 21st to update your code, diagram, whatnot, in the ways you think is good, and we will take a look at that, and you will get a grading, hopefully a pass. And then we only have the third workshop left, so it's not that much left of the course. And the third workshop, it's not that big as workshop number 2, but it's a little bit more advanced maybe, or what you would like to call it. It's you will get some code to work with and add your own modifications to that. So it's not so much coding as in workshop number 2. Feel free to ask any questions, of course, during this time, and we will take a look at the code. This is the old class diagram that we had for the blackjack game with the American dealer and the European dealer. So this should be updated to reflect our new changes. We added the strategy pattern and the rules package and a factory and also the facade, and we will see how things will look now. As a side note, I tried to actually protect the dealer from making mistakes such as this. When we need to create the concrete rules to use, we decided to use a factory, but now we have kind of like 2 ways to create objects. And when you get into the code base, which one should you use? Should I call new or should I use the factory? As a programmer, well, if you have options, there is always a chance that you make the wrong choice. And if it's not properly documented that the way to go, well, you are probably likely to make mistakes. So the design should try to minimize the options and minimize possible mistakes. And one way of that is to, well, now that we had the factory, we could hide the concrete classes of the implementation inside the package. In Java, this is quite easy to do. You just don't make the classes public. In C#, that was not that easy. You basically had to invent a new class. I called it concrete rules, and make it partial. And well, the rule factory is part of this class, and it's a public class, and the concrete strategies are private classes inside this class. So we needed to nest classes in this way. A little bit messy, but doable at least. Not that pretty in my opinion. In Java it is easier and you can do it on the namespace level instead. So that being said, it can be done in C#, but it was a little bit messier than I thought actually. But anyway, this means that if you try to do this outside of this package, I would like to say, but outside of this concrete rules class, you will not be able to compile. So a programmer from the outside can't make a mistake. He can't create the Euro Start New Game strategy. He must use the factory. And this is something you should strive for in your designs. Try to minimize the options to make mistakes. And this is also a classical example of why we don't like static operations. Because if you add a static operation, that is open to anyone to call. And as a programmer, you need to know that, oh, okay, all these static operations also exist somewhere else that I could possibly use. So they kind of like open up the design, break encapsulation, and don't use them. Send arguments to your operations instead. It's much easier for a coder to see, okay, I get these objects sent to me, I should use them to do something, instead of trying to figure out by looking at several different places what to do. So let's move on to the class diagram. Well, the first thing we should notice is that we do have this rules package, so maybe we should add this at first. I will be doing this in Visual Studio right now. It's an okay modeling environment. It's hard to find really good modeling programs that support everything that you need, but this is okay and makes pretty nice looking diagrams without too much fuss. So inside of this package we have the rule factory, the interface for the Start New Game strategy, so let's add those. Interface. And let's add the rules factory. Hide all this so that we get a little bit more compact layout. We have the American Start New Game strategy and the European Start New Game strategy. So something like that then. And we probably have some relations here inside this package. So let's start by figuring out what we have. So we could take a look at this class to start with. Or maybe we could take a look at the interface first. So let's look at the code. What relations do we have here? Basically, what is needed for this interface to work? Yeah, we have 3 arguments to this start new round, and it's a player and a deck. So we have some kind of relation to these classes from this interface. Do you know what kind of relation it is? We have 4 to choose from. Yeah. Is it an interface realization? No, because that's implemented as some kind of inheritance often. Sometimes you have special keywords for this. I think it's implements in PHP, for example, maybe. Extends for inheritance, implements for interfaces. In C#, it looks exactly the same as if you inherit. You type the semicolon and then the type you would like to inherit from or fulfill interface from. So it's not interface realization. Is it generalization, specialization? No, that is, well, inheritance and implementation, so we don't find that. So now the question is it dependency or association? And what is the difference? Dependency? That is correct. Because you only get an association if you have an attribute in the type of this other type you get the association to. So in different languages, attributes are named different things, member variables, fields, properties, or whatnot. In UML, it's called an attribute. Now for a trick question. Can you have an association from an interface? Is it even possible to have it? The answer is no. Because interfaces cannot contain any data or implementation. So this means if I was to add something here, I would technically get an association, but this is not legal in an interface, I hope. So we get an error, and interfaces cannot contain fields, so it's called fields in C#. Yes, a question is here, why is it important to distinguish between association and dependency? Basically, it's a matter of degree of coupling. Dependency is somewhat lighter, and it's somewhat easier to remove dependencies. If you have a association, this means you have one or several attributes of this class, so they are more tightly coupled. And also the notation for the association, you can add multiplicity, and you can add protection level, and you can add the role name. So we have some more information there. So basically you can say that the association is a kind of a stronger coupling than a dependency. You should probably not even be able to use interface realization or inheritance here. I don't think that is legal. for interfaces. So basically, if you see inheritance or something like that, or associations from an interface in a diagram, there is a chance that the diagram is wrong. So we can only have dependencies from an interface. Possibly this is a little bit different in different implementation languages, but this is at least something you should think about when you do your modeling. So basically, here we have arguments of different types, so we should add dependencies in our class diagram. And it was to deck, I think. And it was to player. So, something like that. So let's take a look at the American. And what happens here? We have this interesting part. And that is the interface realization. So let's add that. And we know that these both use this interface, so we can just make it something like that. If we go back, do you have anything more, really? Well, we do have this start new round with the player and the deck. And basically this is something that we get from the interface, so I don't think it's necessary to add those in the diagram. It would only add a lot of more arrows and not say anything more, really. But we do have something else. We have this card here. So we have this type card that we use and call show on it, and give it to the player and to the dealer respectively. So this is a association. Do we have a member variable or a field in American New Game Strategy of type card? No. Then we don't have an association. Then we have a dependency. So, and this is exactly the same thing here. I could do this card this is not an association either, because I only use this object inside of this function, and then it's thrown away, or I'm not at least responsible for it anymore. So it is okay to get stuff as attributes. It is okay to get stuff as return values from some other object. In this case, we ask the deck, could I get the card? And I get the card and I use it, and then I give it to the player, and in this case, and I don't store it in any way inside myself, so it's just a dependency. I can create stuff locally, no problem, call new as many times I want, use a factory to get stuff. As long as I don't store it in a field in C# or an attribute in UML, then we don't have an association, we have a dependency instead. So, but we do have this dependency to the card, so let's add this. Scroll up a bit, I think. There we have card. And I think we have it from the something like that. So that's about it, I think. So let's take a look at the rules factory. What do we have from the rules factory then? Any ideas? Do we have some kind of inheritance? No. So no interface realization, no generalization or specialization in the rules factory. Do we have any fields or attributes? No, we don't. So no association. We have a return value, and we use this type and create a new object. And this means that we do have a dependency to the interface, because the rule factory could not work without the interface. And the rule factory in this instance could not work without the American Start New Game strategy either. So the rules factory has a dependency to this one, and a dependency to this one. And I actually think it's a good idea to put the dependency to the other one, even though it's not really in the code right now. The meaning is that, well, the rules factory do create objects of either this type or that type, depending on something, or it should at least be easy to just change this. So the intent is to have these dependencies in the rules factory. We could just take a look at the properties here, and here we can actually set the visibility of these classes. However, it does not change actually the look of the diagram in this modeling package. I've seen where you get a little minus sign here to visually show that, well, this is part of the package, it's not visible to the outside. So this can be added also in UML to show that, well, these two are just accessible inside of this rules package. And that is a good idea to strengthen the encapsulation that is so important for, that is an important principle in object-oriented software and the design. So as you see, things get kind of messy quite quickly, and it's always a good idea to think about what you're doing when you're doing your class diagrams. What is the purpose of this diagram actually? And if you have the purpose to show some particular aspect of your design, focus on that aspect and make several diagrams. If you're making a focused diagram, well, maybe all dependencies should not be visually shown, because they don't add value to the understanding of what you would like to show in your diagram. However, if you are to actually try to maybe make some refactoring and find out points in the design where it is messy, well, then maybe you should have all the dependencies and all the stuff that is actually in the code present in the diagram also. So depending on what you want from a diagram, think about how detailed you should be. And in this case, we are to show the actual implementation in the design, so we make it very detailed. These two are gone, so let's remove them. We also actually added the facade, so let's do that. I think it was called game facade or something like that. Am I correct? Game facade, yeah. So let's add that one. So, okay, what has happened in the game facade then? Do we have any interface realization or inheritance going on? No. Do we have any fields? Yes, and this means we do have associations in the game facade. So let's add those. And it was to the player. And if you use Visual Studio, it is really messy to remove that one, because you cannot write anything, you cannot remove it, it will come back. So the trick is to make a space. And also, I think that the one multiplicity. Hello. Something weird is happening. Let's go back here maybe. Okay, seems to be back. Something like that, and we have another association to the dealer. And as you can see, I use the field names as the role name here. And that is the standard to go by. So you use the name of the attribute or name of the field in C# as the role name. And I think that's about it for the associations at least. What else do we have? Well, we do this. We create a rule factory. And this means we should have dependency to the rules factory. And what else do we have? We have the game facade. Dealer, player, well, those are already associations. Use the dealer, nothing new here, nothing new here. But we do have this. Card. So the facade cannot work without the cards, because it needs cards to return cards from the dealer and the player. So we need an association, no, a dependency there also. And lo and behold, almost everything uses cards in the card game. That's so strange. So something like this, I think that should be it. But I also think that stuff has happened in the controller, because the controller is not dependent on the dealer or the player anymore. It uses the facade to get this stuff. So we should add a dependency here. because it gets the console view and the facade as as arguments, no attributes. So I think that this should be just about it. And you can see here that, well, the arrows from the controller to the facade, well, we actually could remove one dependency because of this. And this is a good thing. We would like to decouple our packages at the architectural level as much as possible. So it was probably a good design decision to make this facade. The card class, well, that is almost the basic data type in the card game right now. So, well, many things will handle cards. I think that is something that is to be expected. It is almost so much that you could use it as a data type class instead and not draw all these arrows, at least not the dependencies maybe. Possibly there are some refactoring stuff to do here. This arrow is neat. So, and you could always try to make prettier diagrams. That is a job you cannot underestimate if you want to make pretty diagrams. So, any questions on these arrows? We should maybe do some kind of a recap. So basically we have 4 ways to relate stuff. Which one is that? Yeah, so it's called the realization. Sometimes interface implementation and stuff like that. So basically this means that, well, B needs to be an interface. And the A is really realizing or implementing this interface. So it needs to add implementation for all the function declarations that are present in the interface. And this one? Exactly. The messy name. Generalization, specialization, or implemented as inheritance. And this means that A is a more special version of B, a more special type. B is a more generic, general type. B contains implementation that is inherited down into A. B can be abstract if it has abstract operations. And then A needs to implement these. But it can also use polymorphic operations and override implementation in B. We have 2 rules there to look out for, and it's the 100% rule. And this means that A should use 100% of all the, should need all 100% of all the data in class B. So all associations and all data information in B should be applicable in A also. But it's easy to make mistakes there. And the mistakes in inheritance has to do with the Liskov substitution principle that we will talk about on Friday. So inheritance, not that easy as you think. And then we have, well, let's do this one. And that's the association. And basically in the association you have a role, so you have a name here, and you have the navigability, and you often have a multiplicity also, especially if the multiplicity is interesting. And this is implemented by adding an attribute to type A of type B with the attribute name the same as the role name. So inside of this class there will be a field in C# with the type B and the name role. And last but not least, so to speak, you have the dependency. And this is like the weakest form of coupling. And you get this if you don't have an association, but you use another type in some way. And basically there are 4 ways to get a hold of types. You can get them as arguments to the operation. We saw this in the interface. You got dealer and player and deck, I mean. And you can create objects. You can call new inside the operation, use this object, and then throw it away or give it to someone else. This is like the factory. It creates an object, it doesn't store it in an attribute. So it gets a dependency. You can get something as a return type from someone else. So I ask you the deck for the cards, I use the cards, but I don't store them. So I get the dependency to the card. We could see this in the rule variations, the concrete rule variations. And we can also have global variables or static operations that we use. And then we get dependencies to these types. Basically, that's it. So 4 arrows, quite clearly distinguished in the implementation. This should not be that much of a problem. The mistakes that are made are that, well, I kind of like mess up realization with dependency, and I happen to do this. Add the not open arrowhead, but the closed arrowhead, and then, well, the diagram changes meaning quite quickly. And also maybe making the same mistake with the generalization and association. However, that if you have the role and the multiplicity, it's quite obvious that it's an association instead of a generalization. So that mistake is not that common. Looking at the implementation, sometimes some people get the impression that, oh, if I call new, I have an association. But that is not always the case. If you create an object using new or not has nothing to do with what kind of a relation you get, if you get an association or a dependency. It all depends on if you have an attribute. All right. More questions? No? I think it's no idea to start with the composite pattern because it's like 4 minutes to break time. So you can think about this and ask any questions after the break. So 15 minutes of a break.